And welcome everybody to another fun session of our CCNA studies. My name is Keith Barker. I'm a double CCIA and learning new stuff all the time. If you're interested in packet tracer labs or reinforcing knowledge regarding the technologies involved in CCNA 200-301, you're in the right place. So without further ado, let me introduce what we're going to talk about in this content right now. I created a packet tracer lab, and I used it for a couple different purposes. One is I did it for a Subnet Saturday course where we actually carved out blocks of addresses for subnetting to demonstrate how that can be done in Packet Tracer. Lots of fun. And then I also used that lab and I handed it over to Network Chuck and said, hey, Network Chuck, let's have some fun together. Let's collaborate. And what he's done, or what he will do, I'm not sure when he's going to do it, but it's going to be within the next week or so, he's going to create and inject troubleshooting or problems into that Packet Tracer lab and then ship it back to me. And then what I'll do is I will open that up and I will record it live from soup to dessert and walk you through the troubleshooting process. And he texted me and asked or chatted with me and said, hey, how anything off limits here? And I said, please don't give me any spoiler alerts, and whatever you want to throw in is great. So feel free to have at it. So in the meantime, while we're waiting for that, or while Network Check is working on that, I have somebody from the YouTube channel for Keith Barker. His name is Dan, and he said, hey, I asked him in the group, I said, do you want to take this lab and inject problems? And I'd be happy to walk through the troubleshooting and have some fun with it. And Dan said, yes, I'll do it. And so I want to give Dan the shout out for saying thanks for injecting some problems. I'm looking forward to opening up. I'm going to do it right now. Also, if you want to do this troubleshooting lab that Dan has injected, the problems he's injected, I'm going to give you the chance to do it as well. So let me walk you through where you can download the packet tracer file. And if you want to troubleshoot it before you watch me troubleshoot it, please feel free. It'll give us, both of us, more practice hands-on with networking and with troubleshooting. So let's take a look at, first of all, where we can get this file. And I put it on my website at thekeithbarker.com. So if you just open a browser and go to thekeithbarker.com, you can simply go down to the download section or click here on downloads, or just scroll down. And this is the file that I uploaded that we can go ahead and practice with. It's this one right here. So again, this is the handle for Dan, DD153 on my Discord server. And he sent it to me. I zipped it up, put it up here on this website. And so if you want to troubleshoot this packet tracer lab before you see me do the walkthrough or my attempt to solve the packet tracer lab, you can download it right here. Also, if you're new to packet tracer, you can download it from netacad.com, sign up for a free account from Cisco, download packet tracer, and then you can simply open that file and use it. So let me go ahead and do that. Let me download this file by clicking on this arrow and click on save. And while that's downloading, I also want to point out there's the master playlist here on YouTube. It's the CCNA 200-301 master playlist, and I've got 50 plus videos. I add new labs and packet tracer content and training. Well, it's more like it's a mixture of things. It's a lot of live streams is what it is, and some packet tracer labs and reinforcement. So what I encourage you to do is, if you're interested in learning the technologies of Cisco CCNA, take a look at the master playlist. Just go to Keith Barker, go to the playlist. The master playlist is there, and you just scroll through. And if you're new, I'd start at the beginning and just continue to go through step by step by step. All right, so let's go to my downloads folder. There's that file that we just downloaded. I'll extract that and click on extract. And there we go. So here's the troubleshooting ticket. Let me bring it over here. And this one I edited a little bit just to let us know what it is. Packet tracer T-shoot troubleshooting from DD153. Again, thank you, Dan, for getting this for us. And then this is where you can download it, thekeithbarker.com, and the file name is tshoot dd153.zip. I renamed it that when I put this text file and his packet tracer file together. And this is Dan's statement. OGMIT_Keith. That's my handle on Discord. You know what I'm going to take the bait, because I offered everybody, if they want to create some problems in this topology and send it back to me, I'd be happy to walk through it. So he was the first one in, and I'm taking it. So you offered, and so here it is. Don't hate me. I'm not sure what that's about. But anyway, I love the fact that we get to troubleshoot together. And then the clients are having trouble accessing the Cisco website on the server at 10.67.83.3. So in the topology, there's 3 clients, I believe, at least. We'll confirm that. Message me back when I can close the trouble ticket on this one. All right, so let's do it. I have already authenticated with Cisco, so I can open up Packet Tracer. I've already put in my credentials. Let's open up that file, and then I'll resize it to make sure that everything that goes on this screen you can see on your screen as well. Give me a moment to resize that. And let's see, that looks almost good. All right, and let me make it a little bit shorter so that you can see the actual file name all the time as well, which is DD153.pkt, tshoot-DD153pkt. And we scroll this over a little bit to the left and a little bit up. Oh, okay, let me make it a little smaller here. Doink, doink. There we go. And that way we can see the whole topology while we work on it together. All right, so let me get out my pen. And I'm just going to take a look one more time at his task here. Let me drag it over. And it was this. So many screens, so little time. Okay, so the clients are having trouble accessing the Cisco website on server 1067.83.3. All right, so let me minimize that. And let me point out where those clients are. I've got a client here, which is when I set up the lab, initially it was a DHCP client. And there's a client here. This guy's in VLAN 10. This guy's in VLAN 20. And then we have clients out here. Okay, so we have 4 clients, and the internal server is at 10.67.83.3, and the statement was that clients are having problems getting to the internal server. All right. Okay, I'm going to jot that down too, just the fact that we're trying to target 83.3 is the server. Okay, well, let's start off with verifying the symptoms that are being brought up in the ticket. What's the presenting problem that we're trying to solve? And if we go to this PC and open them up, and let me scroll over here and just go to, let's just try to open up a web page and see if that works. So we'll go to desktop and click on browser. And if it does work, hey, our problem's done. So 10.67.83.3. Okay, I'm sold. Request timeout. All right, let's start off with this PC and verify if it has an IP address. Now in Packet Tracer, we can hover over these devices, and it'll give us a lot of information regarding its IP address and default gateway and things like that. And as I'm hovering over this one, the reason I'm laughing a little bit is because I see that it has on FA0, its interface, a 169 address. Another way of looking at that would be to go to the desktop, bring up a command line, and just do ipconfig. That's just the same thing. So the 169 here is bad news. That represents a client that was supposed to be a DHCP client, did a discover probably, and didn't get an offer. So that means it can't reach its DHCP server, which is this internal server right here, which is also on VLAN 10. So let's do this. Let's make sure the server's up. So I'm going to click on the server, and let's make sure the server is actually up. So we can, so I'm looking at the physical view. I see the little green LED there. That looks like it's up and running. Click on services, make sure that DHCP server is running. So server pool is the pool for the VLAN 10, the first network. So that service is on. Let's also make sure that HTTP services are on, which they are. Okay. And let's also go to the desktop and go to a command prompt, just do an ipconfig. And its IP address is 1067.83.3. I thought for sure I'd have some IP addressing issues, but that looks like the right address, and the client, PC1, can't get an IP address. So let's see why PC1 and the internal server can't talk to each other. They're both connected to the switch, so let's bring up the switch. This is a simple layer 2 switch. And go to the CLI. And it's powered on, otherwise we wouldn't have a command prompt. And we'll go into we'll go into privilege mode by typing in enable. And let's do a show VLAN brief. So VLAN 10 exists, that's good. And PC1 and the server are both supposed to be in VLAN 10. Oh, and we're missing somebody. Check this out. FA0/1, let me get my pen out. FA0/1, that interface is the interface right here that goes to the PC, and that's in VLAN 10, but FA0/2, which goes to the DHCP server, is in the wrong VLAN. It's in VLAN 7. So that's definitely part of the problem, or maybe the whole problem. So let's fix that. What we'll do is we'll simply go to interface config for FA0/2, and we'll tell it that it belongs as an access port in VLAN 10. So interface FA0/2, not .2, FA0/2, and switch port mode access, and switch port, access VLAN 10, and show VLAN brief. And if you need a tutorial or a reminder about how those technologies work, check out the master playlist. There's sections on VLANs and trunking and so forth and how that all pieces together. So now those two interfaces, these two are in VLAN 10, which is great. Let's go back to the PC. And at the PC, let's do an IP config / renew. Oh, that looks great. I wasn't expecting it to work. So that's great. Fantastic. It got an IP address. It's .5. And if we look at the server and go to services and DHCP, that's the first valid IP address that it's handing out from that network, which is great. All right, so PC1 and the server are now both in VLAN 10, which is correct. And let's go ahead and do a ping. Let's ping to 10.67.83. That's the server's IP address. Make sure that's in frame. It is. Oh, that's great. And we could also go to the switch and do a show MAC address table, like that. So the reason I'm frowning here is I don't see any ports over here that say that it learned MAC addresses on FA0/1 or FA0/2. Maybe it's just a really fast timeout, or maybe so let's go back to PC1. Let me do a ping again to the server. Let's go back to the switch and do this up arrow command. Oh, there we go. So it looks like Packet Tracer has a hypersensitive timeout for MAC address learning. On a real switch, it would be minutes versus moments. In any event, I just wanted to confirm that it learned two MAC addresses, one on FA0/1, one on FA0/2, and those would represent the server and the client. And because we can ping, I think we've solved the problem between PC1 and the server. So let's go ahead and test that. We'll go back to the PC, go to, I'm at the desktop tab, I'll close this command line interface, and I'll simply click on web browser, and we'll go to HTTP is going to be the default here. So 10.67.83.3. Oh. So so let's talk about this for a moment. We're on the same local VLAN between PC1 and the server. So as far as the server resetting that connection, what would cause that? If we were going through a router or a firewall that might do a reset based on an access control list, or but there's nothing between that. And on this switch, it's just a simple layer 2 switch. So I doubt that we have, and we can ping. Let me just go back real quick and make sure that we can do a ping. I didn't do the wrong address. So we'll do a ping. That's the server's address. And if we do an ARP-A, that'll show us the ARP cache. So that's the layer 2 address it thinks of the server. Let's go to the server real quick and go to desktop and ipconfig/all. And sure enough, that's the MAC address. Okay, so there's no trickery or mischief happening at layer 2. They're in the same VLAN. Let's try it again. Huh. Okay, so back to the PC. And I'm going to close desktop and go to a browser prompt again. And 10.67.83.3. Is that the right address? Yes, it is. Server reset. So because the MAC address is on the switch, we're on those two ports, I was thinking maybe the switch got tricked to forward a different direction, but it wouldn't know anything about a ping versus HTTP. Ah, this is great. It's fantastic. Well, let's make sure the server is running. I think I already checked that, but let's check again. So we'll go back to the server. And on the server, we'll do a click on services and HTTP. It is running. Because if it wasn't running, we'd more likely expect a timeout. You know, another thing we can do is when troubleshooting, we go really close to the source. And all right, Dan, good job. I have no idea why this PC cannot hit that web server. Let's go to the server, which we're on right here, and let's go to its own desktop, and let's just open a browser to itself, just to see. That will rule out the network. So if a server can connect to itself and it works, then we know the service is running and there's no trickery going on there. So 10.67.83.3. Oh. All right, so the server can't even connect to its own web service, which would lead me to on a system to think that it was either filtered or we had some filtering going on. So under HTTP, let's see if we have any weird AAA authentication. There's nothing regarding authentication here for HTTP services that would be preventing that. So this is all the default content for the web server. So when you go to the web server in Packet Tracer, it has the copyrights and the hello world and a small image and the default page. Huh. I'm curious. All right. So locally, if we go to desktop, he gets the same message, same reset. I wonder if we tried HTTPS. Let's go back to services, HTTP. HTTPS is on. Let's try HTTPS. Go. Same message. Oh, okay. All right. Well, let's do this. This is great. We had a couple of ports that were in the wrong VLANs, and now we corrected that. I verified the layer 2 switching. We verified the MAC addresses, and now this server can't even talk to its own web service. And in a production environment, on like a Linux box or something else, I would think that there might be access control list or filtering in place, but I don't think those access controls exist inside of Packet Tracer. So let's go to services. And let's take a look. So by default, this web server, when it hits, the default page is going to be index.html, and then there's the other options that we can click on from that page. Let's take a look at the landing URL. This is new territory for me. So we can delete it, edit. Let's edit it. So HTML. Packet Tracer, welcome to Packet Tracer, opening new opportunities. That has the links for Hello World, copyrights, image. What? Oh my gosh, you did. Oh my gosh, this is so great. Oh my god, look at these tags. So basically this tag with that exclamation mark, I have to brush up on my HTML, but that looks like a remark statement. And the close bracket for that, or the close ending tag, is right there. So basically oh, this is fantastic. Dan, thank you. This is fantastic. This whole thing is just a comment, meaning it's not acting on. And the only thing that's going to show up is this message right here. Server reset connection. And how about I'm going to replace that with got me. Let me just save it as a test. I think that's what's going on. And let's go ahead back to the desktop and go. Yeah. Way to go. I'm going to clean up that text message. So we'll go back here, and I'm going to take that out and modify that, close, and that open, and save it. Oh my gosh, that is so mean. That's so fantastically mean. Let's go back and try it. Back to the desktop. Go. Yeah, there it is. Wow, you have me looking at layer 2 or redirecting or access list or filtering. So we did have some ports that were wackadoodle, but we also, the main problem was the fact that they spoofed the source page, or you rewrote the source page, the default page for the website. That is fantastic. But we're not done. We have 2 more clients. So let's go over to client 2. It has an IP address, looks like. I just want to verify we can hit the server from all the clients. So go to desktop, browser, and 10.67.83.3. Looks good now that we've cleaned up that page. Because if we didn't clean up that page, they would all get that reset message, because that would be the default homepage message. Ah, so good. And let's go down to Site A client, the Site A PC, and go to desktop, command. Well, let's go to a browser. And we're going to get, I think we're, unless there's another problem, I think we're good to go. 10.67.83.3. All right, that looks good. And let's one more client, Site B PC here. And desktop, browser, 10.67.83.3. And that works too. Oh my gosh, what a great lab. So if you've already watched this, the cat's out of the bag regarding Dan's problems he injected, But if you have somebody else you'd like to have run through this, have them go to the beginning of this video, have them stop after it shows how to download it, and then have them download it and test it, because this really was fantastic. And I'll tell you why. There were some problems with the 2 ports for the PC and the web server being in the incorrect VLANs based on the access port assignments on the switch number 1, the access layer switch. But beyond that, there was also, when you hit that web server, the default page that I was expecting wasn't happening. So if we put a protocol analyzer on this network, we would have seen a TCP 3-way handshake and then the initial page be fed down to the client. And we would have seen, wait, it is working. We are getting a web page. It just happens to be that the content for that web page wasn't the default of what I was expecting. So what a great way to set up a problem in a lab, because it made me think. I was thinking about layer 2, looking at ARP caches, looking at the MAC address tables on the switches and where was being forwarded. And there's so much more that can be done in this lab as well. So anybody who wants to, if you want to, let me show you where it is again. If anyone would like to grab the lab, and let me show you where the initial lab is so you can grab it. Let me get the right window here. That'd be this one right here. So the initial lab, if you want to, the initial one that I had, that Dan got, and you can too if you'd like to, is this one right here. It's called Cisco PT IPv4 subnets. I used it to help do some subnet Saturdays with Packet Tracer. Check out that video as well if you're interested. But this is the lab that's a fully functioning IPv4 lab with OSPF, with HSRP and NAT and all these other technologies. And if you want to grab that lab and then inject your own problems into it and submit them to me, Discord is the best way to do it on the Discord server. I will put a link in the description of this video of how to join us on Discord. And if you'd like to, just DM me and say, here's the Packet Tracer lab. I put some problems in it. Good luck. And I probably have a few pile up, but I would be happy to take those periodically and do a live walkthrough. This was great, by the way. This was way tougher than I thought it would be. So my hat's off to Dan for creating that scenario for me. But if you want to take this lab right here, just download it from thekeithbarker.com, mess it up a little bit, and specifically say what the problem is, like this client can't get to that web server or whatever you want to specify, and then I'd be happy to do walkthroughs. I had a great time in doing this. Also, coming up, Chuck Keith has got this lab as well that I gave him about a week ago or so, and he's scheduling time to inject problems in that for me. I will also do that as a live video to walk through the solution of that lab. And he asked me, how tough do you want it to be? And I said, everything's fair game, because I'm familiar with the topology because I created the Packet Tracer lab, that one. This one we just talked about, pre-problem, without the problems. And so he said, great. And he's going to put get some feedback and put some problems in it. And then I will record that troubleshooting as well. And I'll do that live. Also have the opportunity for you, if you want to download it first and then do your own troubleshooting before I do the walkthrough, that would be great too. So I'll announce where it is and give you a chance to do that as well with the one that Network Check does for me. So thank you very, very much for joining me in this video about troubleshooting using Packet Tracer as an opportunity to hone our troubleshooting skills. And I look forward to seeing everybody in a future video. Thanks, everyone.